Yes, hi everyone. So welcome back to Power Systems 2 online series. Thank you for listening till today regularly the online classes. And today, let us we are going to see one more interesting topic, which is called representation of long transmission line. So already it is covered in the medium transmission line. So whatever we see the representation of medium transmission lines, the same concepts in the same procedure we will see here also. But what is the difference? In the sense, the difference is in the earlier topic it was related to medium transmission line, now it is related to long transmission. Yes, that is the difference. Yes, now we keep heading, that is representation of long transmission lines. Representation of long transmission. So here also we have the two procedures. The first one is nominal T and second one is nominal pi. There are two procedures are there to represent long transmission lines. Those are, the first one is nominal T method and second one is nominal pi method. Yes, first let us see nominal T method. Nominal T. Is nominal T. So here let me draw the same circuit. So whatever the circuit we had at that time, the same circuit let me take. But here in the case of medium transmission lines, I consider only capacitor in between the two impedances. That is the at midpoint of the transmission line. But here in the place of capacitor, let me take admittance. Yes, admittance in the sense it is the parallel combination of both resistance and capacitance. Okay, yes, it is like this. And so what we do, let it be, this is Y. Load is connected at receiving end, and here let us we assume sending end. The voltage at sending end is Vs. Voltage at sending end is Vs. Let us we take the current is Is, and let's assume the impedance is Z by 2 here, and this is also Z by 2. So let this current is IR, and let it be this is VR. This node voltage is V1, that is voltage across the shunt branch, like this. So let this current is IC, that's where IC is equal to Y into V1. Okay, so now the voltage across load is VR. Yes, the equivalent T network of long transmission line is determined to represent the line accurately by assuming suitable values of lumped constants. Okay, so now let us write the equations. So what are the equations? The first one is, what is V1? What is node voltage? V1 is equal to, yes, if you apply the KVL here, you may have the equation, that is V1 is equal to VR plus IR into Z by 2. Yes, this is the equation for V1. Then second equation is, what is Is? Apply KCL at node 1. Yes, when we apply the KCL at node 1, what is the equation? Incoming currents is equal to outgoing currents. That is, sum of incoming currents is equal to sum of outgoing currents. Sum of incoming currents are IS only. IS is equal to IR plus IC. IR plus IC. Yes. Now, what is the third equation is, what is equation for IC? Yes, what is equation for IC? Yes, what is equation for IC? Yes, here IC is equal to V1 into Y, where V1 is, what is V1? VR plus IR into Z by 2 into Y. VR plus IR into Z by 2 into Y. Okay. So this is how we got the equations. The four equations are there. Yes, what are the four equations? First we have written V1. Next, second we have written the equation for IS. And third we have written IC. Okay. And at last final, fourth we can written the equation for IS. Again IS in terms of VR and IR. So let me write all these things. Yes, here what is equation for Vs from the circuit diagram? Vs is equal to V1 plus Is into Z by 2. Yes, but you know that V1 is VR plus IR into Z by 2. And what is IC? IS is IC plus IR. IC plus IR into Z by 2. Okay, and therefore Vs is equal to VR plus IR into Z by 2. IR into Z by 2. IR into Z by 2. And the next one is IR into Z by 2 plus IC is V1 into Y plus IR into Z by 2. Now we know that what is V1? V1 is VR plus IR into Z by 2. This is VR plus IR into Z by 2. Again we write the same thing. So this is into, not here. Okay. Plus V1 in the sense VR plus IR into Z by 2 into Y plus IR this into Z by 2, that into Z by 2. So let me write clearly. That is Vs is equal to VR plus IR into Z by 2. Again V1 into Y, that is VR plus IR into Z by 2 into Y plus IR this whole into Z by 2. Yes, now we common the terms, that is we separate the terms of VR and IR. So then Vs is equal to, where we have the VR, here we have one VR, this is 1 VR, that is here it is 1 plus this is YZ by 2 into VR plus IR. Yes, here IR is there, this is there, so hence IR Z by 2 plus Z by 2, this is Z only, Z by 2 plus Z by 2. Yes, let me write Z by 2 plus Z by 2 plus Y Z square by 4 into IR, or you can also write this equation as 1 plus YZ by 2 into VR, and Z by 2 plus Z by 2 is Z, and if you common the Z, then it is 1 plus YZ by 4 into IR. So now let us compare this equation with Vs is equal to A into VR plus B into IR. Let us compare this equation with Vs is equal to A into VR plus B into IR. Okay, shall we compare? Then what is the equation for A? A is 1 plus YZ by 2 and B is Z into 1 plus YZ by 4. That is, when we compare the equation with Vs is equal to A into VR plus B into IR, then A is equal to 1 plus YZ by 2 and B is equal to, yes, what is B? Z into 1 plus YZ by 4. The same expressions we got in the case of medium transmission. Okay, yes, the next one is this is AB. Next we need CD. First that such CD, let us take descending end current. What is IS? IS equation is IC plus IR, where IC is V1 into Y plus IR. Now what is V1? VR plus IR into Z by 2 into Y plus IR. Okay, so now we separate the VR terms and IR terms in IS equation. Yes, so how many VR terms are there? Only single term is there, that is VR. How many IR terms are there? There are two terms are there, those, this is one and this is one. So if you separate those two, then we have IS is equal to, yes, IS is equal to Y into VR plus 1 plus YZ by 2 into IR. Now we compare this equation with IS is equal to C into VR plus D into IR. So then what is C? C is equal to Y. And what is D? D is equal to 1 plus YZ by 2. So now here you can prove that A is equal to D and AD minus BC is equal to 1, as we prove in the case of medium transmission line. Yes, as we prove in the case of medium transmission line. Yes, already the topic is over. So hence I want to take this topic to some more extent. That is, if we know in the problem, so when they give the values of ABCD constants of long transmission line, then how you find out, how you find the values of line impedance and line admittance. Yes, let us do that one. Yes, from the ABCD, C is equal to Y. So hence what is shunt admittance? Y is equal to C only. That is Y is equal to C only. Then what is Z? What is Z? Just tell me what is Z? See here, just you see. Yes, let me take first A. Let us we take A. A is equal to 1 plus yz by 2. Yz by 2. In the place of y, let me substitute the value of C. So then it is A is equal to 1 plus Cz by 2. So here I need the value of Z. So hence Z is equal to 2 into A minus 1 divided by C. 2 into A minus 1 divided by C. Okay. So if suppose the value of Z is real and imaginary, the real term corresponds to the resistance and imaginary term corresponds to the reactance. And if we know the frequency, then we can easily find out the series inductance of the line. Okay. Yes, this is like this. And similarly, let us do the same procedure for nominal pi method. Yes, next keep side heading nominal pi method. Yeah, here let me draw the diagram. Of course, this is the last topic in the third unit. Yes, with this the third unit is over. This is receiving in. Let us assume Vs Is. So here let it be, this is y by 2 and here also y by 2. This is load. This is IC1, IR, IC2. This is IL, that is current flowing in the transmission line, and here as usual the impedance is there. That is, the shunt admittance is assumed to be lumped at the both ends of the transmission line. Sometimes the equivalent pi network of long transmission line is required to be determined to represent the line accurately by assuming suitable values of lumped constants. Okay, as let us we assume the transmission line having auxiliary constant capital A, B, C and D be represented by the pi network. So here we can write the equations as two nodes are there. Let it be, this is node 1 and this is node 2. Two nodes are there. And when we apply the KCL at node 1, what is equation? IL is equal to IR plus IC1. Yes, if it is so, then what is IC1? IC1 is equal to VR into Y by 2. VR into Y, because the load and shunt admittance are connected in parallel. Hence voltage across each is same. Therefore it is VR into Y by 2. That is the value of IC1. Okay. Next, this is two equations we got, and if we substitute this value in IL, so hence IL is equal to IR plus y by 2 into VR. IR plus y by 2 into VR. This is an expression for IR. Okay, do you got this? Yeah. Then now let us we apply the KCL at node 2. KCL at node 2. KCL at node. What is the equation? IS is equal to IL plus IC2, and we know that IC2 is equal to IC2 is equal to Vs into Y by 2, because sending end voltage and shunt admittance are connected in parallel. So hence Is is equal to IL in the sense, what is the equation for IL? Yes, IL is equal to IR plus VR into Y by 2 plus Vs into Y by 2. Yes, if it is so, what is Vs? How you write Vs equation? Yes, let it be as it is. Now we write the equation for Vs. Yes, Vs. If you apply the KVL in the middle loop, then Vs is equal to, that is node 2 voltage. Node 2 voltage is equal to node 1 voltage plus drop in the line. Node 1 voltage is VR plus drop in the line transmission, that is IL into Z. Yes, this is VR plus IL into Z. What is IL here? Yes, what is IL? VR plus Y into VR by 2 into Z into Z. So then you can write this equation as, yes, if you separate VR terms and IR terms, then you may have the equation as 1 plus YZ by 2 into VR plus sorry, it is not VR, it is IR. 1 plus YZ by 2 into VR plus IR into Z. So therefore, if you compare this equation with Vs is equal to A into VR plus B into IR, then you may have A is equal to 1 plus YZ by 2 and B is equal to Z. As we got in the case of medium transmission line. This is also same. Okay. Now again we go to the sending end current. If you substitute these values, that is Vs value, the equation for sending end current is 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 equal to, yes, if you separate the VR terms and IR terms, that value will be Y into 1 plus, directly I am writing this equation, 1 plus YZ by 4 into VR plus 1 plus YZ by 2 into IR. Now we can compare this equation with Is is equal to C into VR and D into I. Okay. So hence we got ABCD constants of long transmission line as for nominal pi representation. Nominal pi representation. So now let us see if suppose in the problem, yes, let me extend this topic. If suppose in the problem if they give the values of ABCDs and they ask to find the line series impedance and shunt admittance, then how you find? Then how you find? Yes, it is very simple. Thus, what is the equation for B? B is equal to Z. So directly we got Z is equal to B. This is next. What is A? A is equal to 1 plus YZ by 2. So now you substitute in the place of Z B. Sorry, in the place of Z B. Yes. Then A is equal to 1 plus Y into B by 2. 1 plus Y into B by 2. So hence Y is equal to 2 into A minus 1 by B. So hence if you have the values of ABCD, then you can easily find out series impedance and shunt admittance of transmission line. Yes. Now let us solve one problem. Let's write down that a long transmission line has a long transmission line has the following auxiliary constants. The following auxiliary constants. Yes, he has given. Yes, written that Z is equal to. Sorry, it is not Z. Yes, in ABCD values. A is equal to D is equal to 0.945 at an angle of 1.02 degrees, and B is equal to 82.3 at an angle of 73.03, and C is equal to 0.001376 at an angle of 90.4 Siemens. Then determine first one, equivalent T network, and second one, equivalent pi network, equivalent T network, equivalent pi network. As in the case of long transmission line, they used to ask equivalent T and equivalent pi instead of nominal T and nominal pi in some cases. But equivalent T in the sense it is equivalent nominal T network only, and equivalent pi in the sense it is nominal pi network. Don't get confused. Okay. Now let us go to. So first, let me solve this problem. The first one is equivalent T network. So first to draw the T network. Yes, so how T network is there? Z by 2, and this is y, and here we have low. Yes, in each and every case you need to draw the circuit diagram. Yes, if you draw the circuit diagram, you may get some impression from the examiner. That is, he knows something like that. Yes, that's it. This is equivalent T network, and for equivalent T network we have to write expressions for Z and Y. Yes, first, what is Y? Y is equal to C is equal to it is not C, it's omega C. Y is equal to J omega C is equal to, sorry, Y is equal to C only. That is, it is not capacitor C, it is C, ABCD constant C. So hence what is this value? 0.001376 at an angle of 90.4 degrees. You can substitute this Y value here. Okay, next. Yes, next one is, what is Z? Yes, Z is equal to 2 into A minus 1 by C. Because don't get confused, for nominal T and nominal pi, just slight changes are there. In the case of nominal pi, Z is equal to B. In the case of nominal T, Z is equal to 2 into A minus 1 by C. And in the case of nominal pi, Y is equal to 2 into A minus 1 by B. But whereas in the case of nominal T, Y is equal to C. But don't get confused. Do practice more. Yes, next. Yes, what is this? Now you substitute all these values in this equation. Find out the value. Is 2 into 0.945 at an angle of 1.02 minus 1, A minus 1 by C. What is C? 0. Is 0.001376 at an angle of 90.4. Yes, 90.4. Yes, then what is numerator? Yes, what is numerator? This is given by, what is numerator in the sense, 2 into minus 0.055. You check all the answers. 552 plus J 0.0168 divided by 0. Yes, what is this? 0.001376 at an angle of 90.7. Yes, if you find this value, how much you have? Totally z is equal to yes, z is equal to, you make it 167.75 at an angle of 72.6 degrees. This is impedance value for nominal t, and we repeat the same procedure for nominal pi. Repeat the same procedure for nominal pi, that is equivalent pi model. Sorry, in the case of long transmission line, we represent that as equivalent pi model. Let's draw the circuit. Let's draw the circuit. Yes, the center. At center you have the Z. The current here is IL, and here you may have the shunt admittance. This is load sending in. Okay, y by 2 load. Now what is the equation for Z here? Z is equal to B. What is that value? That is 82.3 at an angle of 73.03. And what is y? Y is equal to, what is equation? 2 into a minus 1 by b. Okay, now you substitute a and b values here. A and b values there, then you may get approximately. Just you check all these answers. I am writing directly. Yes, that is 0.001401 at an angle of 89.97. That is approximately 90 degrees. Yes, this is how we can able to solve the problem as in the case of long transmission lines. Okay. Let's write one more problem. The ABCD constants of long transmission line. ABCD constants of long transmission line are A is equal to D is equal to 0.9 at an angle of 0.6 degrees, and B is equal to 153.2 at an angle of 84.6 degrees, and C is equal to 0.0012 at an angle of 90 degrees. Then determine equivalent T model and pi model of long transmission line. Equivalent T model and pi model of long transmission line. Okay, now you solve this problem. it as homework or work. Solve this problem. This in previous class also I have given two problems, but I think no one has solved the two problems. The practice is required for you. Without practice, the subject is somewhat difficult because the entire subject is derivation problem like that. Okay, yes, thank you for watching this. Stay home, stay safe. While you are going to the outside, take some precautions. Thank you once again.